Good day everyone, and we are welcome to today's class again with overs of the Eminence Academy in our mathematics classes. And today we'll be talking about one concept of mathematics, which is the numbers and their types. Now, in our last class, I explained that when we talk about numbers, we are talking about intuition or feelings of increments and decrements. But to set these feelings of increments and decrements needs some symbols to represent the quantity of the entities that has been increased or decreased. So these symbols are what we called numerals. So numerals, as I said, are just the symbol used to represent numbers, right? So, and they say that example of that are the ones that we call the Roman numerals. The Roman numerals, the likes of I, IV, L, C, M, in that respect. So now, these ones, they are the Roman numerals, that is the symbol used by the Romans to represent number. So when I said that the majorly used one, the generally used one, are the one that we call the Indo-Arabic numeral, the Indo-Arabic numerals, which are the 1, 2, 3, 4, up to get to 9 and 0 inclusive. So these numerals now, we can now interchangeably call them numbers. So when I say numbers in this concept, I'm talking about numerals precisely. So now, so these numbers that we now have, we have types of numbers. So the very first type of number I will talk about is the natural number. Types of number is the natural number. The natural number. You know, when we say something is natural, what does it mean? It means the thing is fundamental, it is basic. So the natural number by definition, we say they are numbers that can represent the length of a line, but that can bring about some misunderstanding. Or so why do I say that? When we say numbers that can be used to represent the length of a line, we can have a line and say this line is 25.3 centimeters long. So this is the length of the line, but this number that we use to represent this length of a line is not a natural number. So in my concept, I will say that natural numbers are counting numbers. They are counting numbers. So any numbers that we can use in counting, they are called the natural numbers. And if you don't forget, in the first video we had earlier, I explained that mathematics actually originated from counting. So these are the numbers that actually that brings about mathematics. So natural numbers are counting numbers. When we want to count something, we always start with 1, 2, 3 in that respect. And the symbol for natural number is this. The symbol for natural number is that. So the other number that we have is the integer. The integers. When we say integers, though, we have two. We have the positive integer and we have the negative integer. The positive integer and the negative integers. So the positive integers are the counting numbers, which is the natural numbers, with a 0. The counting numbers and 0. These are positive integers. And what are they? We have it to be 0, 1, 2, 3 in that respect. While the negative numbers are just the negative of the natural number, which are just -1, -2, -3 in that respect. So generally, the integers, if you just say integers, it is denoted with this symbol. That should be integer. But to indicate that it is positive, we put to the power of plus here. While to indicate that it is negative, we put a minus. So that is integer. But generally, integer will just take that symbol Z to indicate that it is an integer. Now, the other one that we have is the one we call the rational number. The rational number. By definition, what we say rational number? By definition, rational numbers will be called numbers that can be expressed in A over B form. numbers that can be expressed in A over B form, and this may bring about some misunderstanding. What do I mean by that? If I say numbers that can be expressed in A over B form, what about if I have pi? We know that pi can be expressed to be 22 over 7, right? But 22 over 7 is not a rational number, and it has been expressed in the form of A over B. Again, if I have 1 over 2, it is a rational number and it is also expressed in A over B. So what makes this, on the fact that it is expressed in A over B form, what makes it to not be rational, and what makes this particular one to be rational? So what I will give as definition of rational number is that rational numbers are numbers that, if converted from their fractional form to decimal form, it will give a truncating decimal value. It will give a truncating decimal place, or let me say decimal values, any of the two. So what I mean by to give a truncating decimal value, we know that if I have 23.294, all this that I have before the decimal point is called the characteristics of the decimal number. The characteristics of the decimal number, and this one are called the mantissa of the decimal number. So if I have a number in the fractional form, and in the course of converting it from its fractional form to the decimal point, this mantissa assumes a definite number of digits, like this one now. It has just 3 digits after it, without any rounding up or rounding up. The condition is there. So if conversion of the number to decimal form gives a unique number of decimal places, then the number is rational. Example is 1 over 2. 1 over 2 will give me 0.5, right? So I have just to be in a decimal place. So if I have something like, let me say 21 divided by 2 again. So 21 divided by 2, that will give me 10.5. Right? But as of this 22 over 7, if you press 22 over 7 into calculator, it will give a non-truncating decimal value. To give a 22 over 7, and we convert 22 over 7 to decimal places, that will give us 3.142857142857142857 in that respect. So this value will actually ends. These decimal values, these decimal places, will actually ends at where the capacity of the calculator is. If you have a calculator which strength is not more than this, it can just be 3.14286, because it will approximate the 7 to 5. If you have a bigger one that its strength is as big as this, it can give us 3.142857143. So this one, it means that it doesn't have a truncating decimal place. So that is what we call a rational number. A rational number is a number that has a truncating decimal place. That is, after, in the process of converting it from its fractional form to its decimal form, the decimal place assumes a unique number of values. So, and the symbol for rational number is this. So we represent a rational number as this. Okay. So after then, we now have what we call the real numbers. The real numbers. When we say the real numbers are numbers that do not have the roots of negative in its computation. A number that does not have the roots of negative in its computation. For instance, let's say we have this quadratic equation to be solved, 2x squared plus 3x plus 1 equals to 0. I want to use the formula method, which we'll later be talking about. We are going to have x to be equals to minus 3 plus or minus square root of 3 squared minus 4 times 2 times 1, all divided by 2 times 2. So we have x equals to minus 3 plus or minus the square root of 9 minus 8, all divided by 4. And we have x to be minus 3 plus or minus the root of 1 over 4. So in the computation of this particular number, the roots value does not take a negative root value. It is not negative root value. So any number that does not have negative roots of negative value in its computation, it becomes real. So, and the symbol for real number is this. Why, as for the last one, is what we call the complex number. The complex number. So the complex numbers are just the opposite of the real numbers. So what are complex numbers in that case? There will be numbers that have the root of negative in its computation. And the root of negative we take, if I have root of negative a, it can be written as root of a multiplied by the root of minus 1. So the root of minus 1 alone is known to be I. So we can now say anytime we have an I in the computation of some numbers, then that number or those numbers are complex numbers. So the symbol for complex number is this. So now, on the review of all we said we have types of numbers: the natural numbers, the integers, the rational numbers, the real numbers, and the complex numbers. So the natural numbers, as I said, are the counting numbers from 1 upward. The integers, we have 2 of it. We have the positive, we have the negative. So the positive is the natural number including 0. Though 0 is not a natural number. So the natural number including 0 gives the positive integer, while the negative of the natural number gives the negative integer. And we talk about the rational numbers. The rational numbers are numbers that in their fractional form, when converted to decimal form, it gives a truncating decimal places. Why, if it does not give a truncating decimal places, it is called a rational number. Irrational. So if it does not give a truncating decimal place, it's called a rational number. Then from there we discussed real numbers, and I said real numbers are numbers that do not have the square root of negative in their computation. While for complex numbers, they have square root of negative in their computation. So now, the next thing I want to do now is to link these numbers and see the relationship between them, because I will be using this in our next video of some other topics that I will be needing to talk about real numbers with respect to natural numbers, integers with respect to complex numbers in that respect. Now, so before I go into that, there is one of the topics we'll be talking about, which is set theory. Set. So in set, I only want to make use of 2 things: the subset and the superset. The subset and the superset. Now, when we say sub anything, subdivision, subtopic. So anything that is sub, it means something that is gotten from the other. Like for example now, when we say a subtopic, that means we have a topic we are treating. Like now, we say we are treating numbers. We now bring another topic under that number, which is types of numbers. So when we say subset, we are talking about a set that is gotten from another set. So the symbol for that subset is this. So if I say A is a subset for B, or a subset of B, what I mean by this is that every element, everything that is in A must be in B. Like, let me use this. Let's talk about a country and a state. If a country has 15 states, for instance, every citizen of any state we may pick here, must compulsorily be a citizen of that particular country. Let me use Nigeria for example. In Nigeria, we have Kano State, we have Oyo State, we have Kwara State. So all these states, if I use, let me use another thing. Let me use maybe Edo State. So if I use E to represent Edo, I use O to represent Oyo, and I use K to represent Kwara. If someone can say I am a citizen or I am an indigene of Edo State, that means compulsorily the person is a citizen of Nigeria. That's very certain. If someone says I am an indigene or I am a citizen of Oyo State, compulsorily the person must be a citizen of Nigeria. The same thing goes for Kwara. So that means that for this, I can say that the Edo is a subset of Nigeria. So for subset, what is in the first set, everything without excluding one, everything in this first set must be in this second set, but not the converse. Not everything, not being a Nigerian doesn't mean that you must compulsorily be from Edo State. It doesn't mean you must compulsorily be from Oyo State. It can be from any other state. But if you are in any of these states, then it means you're already in Nigeria. That's the meaning of subset. So the opposite is now the superset. That set that leads to the subset is now the what? The superset. So in this case, Nigeria will be the superset of all this. Now, so if that is clear, let us now see how we can link this. How we can link these numbers. So how can we link these numbers? If we go by their definition, we will see how we can link them. Now, as for natural numbers, we say natural numbers are discounting numbers, which means that if you look at discounting numbers in relation to natural, the integers, we can see that every number that is a natural number happens to be a type of integer. So any number that is a natural number will compulsorily be an integer, but not all integers are natural number. Every natural number is an integer, but not all integers are natural number. For example, now pick any natural number. Let me pick 20. If I pick 20, I can say 20 is an integer, a positive integer. Right? But if I can pick some integers and it will not be natural number. Example is 0, and example for all this negative natural number. So in that case, I can then say natural number is a subset of integer. So again, let's look at that of integer and that of rational number. In the definition of rational number, I said it is a number in which, if taken from its fractional form to its decimal form, it gives a truncating decimal place. That is, the matricer will assume a unique number of values. Now, so if I now pick some natural numbers here, let me say I pick 5, which is a natural number, which is also an integer. Now, if I pick 5, I can say that 5 has a denominator of 1. That's so clear. Why? Because the denominator of a number, if I use it to divide this particular number, 1 divided by 5 divided by 1, I will still have 5 back. So anything divided by 1 is still that same number. So I can say 5 is the same thing as having 5 over 1. I've tried to take that number to put it into a fractional form. And if I try to convert this one to decimal, I'll still have it as 5.0. I can have it as 5.00, I can have it as 5.00000. But a rule that is all known is that if zeros end some decimal numbers, zeros that end decimal numbers are not useful. How? Okay, let's look at this. I have 2.5. I have 2.50. I have 2.500. So I'm now telling you that this 2.5 is the same thing as 2.50, the same thing as 2.500. Let's try to convert these numbers to their fractional form. To convert a decimal number to fractional form, what do? We write all the numbers together. So we have 25. For this, I will have 250. And for this, I will have 2,500. So after that is done, I will now divide by the number of digits I have after decimal points will determine the number of zeros I will have in the denominator. So as for this, it will be divided by 10. Why for this to be divided by 100? For this to be divided by 1,000, because I have 3 digits after it. So by no division, this 0 can cancel 1 0 here. These 2 zeros will cancel 2 zeros here. So here, let me still leave this as 25 over 10. This one will still remain being 25 over 10, while this will still give me 25 over 10. So why is it like that? It is like that because the zeros that ends, please don't make a mistake, the zero that ends, I don't say the zeros in decimal. Okay, what I mean by that, if I have 2.501, this 0 now is useful because it is not what that ends it. If I have 2.000000001, all these zeros are useful, they are not going to end the decimal point. But if I go ahead to go and have 2.103200, this is useful, these are not useful, they have nothing they want to do there. So, except we are talking about, we are talking about the measuring accuracy of some instruments and estimated. That's another thing entirely. But when computing numbers, they have nothing they want to do there. So that implies that when I have 5 over 1, I go back there, it is the same thing as 5.0. Same thing as 5.00. So depending on how many zeros you wish to put there, it will always be a truncating value. So if I'm going for 5.0, it means it is a rational number, though it was gotten from an integer. So even if we go for a negative integer, we have the same thing. Minus 3 over 1 will give me minus 3.0. So that implies that I can also say that an integer is a subset. Integers are a subset of what? Rational number. Integer is a subset of rational number. And the next one, we have the real numbers. I said the real numbers are numbers that do not have negative roots of negative value in their computation. And as of all these numbers we've been doing, we don't have any that have root of negative. This has negative, not root of negative. I don't say numbers that have negative, no. Numbers that have roots of negative in their computation. So that means that all these numbers up to the rational numbers are subsets of real numbers. But as for the complex numbers, I said complex numbers are numbers that have what? The root of negative in their computation. So we say a complex number, if I say a complex number z is equals to x plus iy. What makes it be complex is because of this I. As I said earlier, that I is the square root of what? Of minus 1. I is the square root of minus 1. So I can form some real numbers from this by what? By letting y to be 0. So if y is 0, and we have z to be equals to x plus I multiplied z by 0, and I will have z to give me x plus 0, yz will be equals to x. There is no I anymore. Which means I can say a number that happens to be a real number, it's a real number because it's imaginary part. Because for complex number we have two parts. We have the real part of the complex number, and we have the imaginary part of the complex number. So the real part of the complex number is the part that does not take the I, while the imaginary part is the part of the complex number that takes the I. So I can say that any real number is gotten from some complex number whose imaginary part is 0. For example, I have minus 6 over 3, or let me say minus 6 minus 7 over 2. Minus 7 over 2 is a real number. Why? Because it does not have I attached to it. But I can say that it is similar to having plus 0i. It's the same thing. Because 0 multiplied by I will give me 0. And if I add 0 to this, it will still remain being minus 7 over 2. Which implies that I can say that a real number is gotten from a complex number whose imaginary part is what? 0. Then conclusively, real number is a subset of complex number. So that is that for now about types of number. So in our next class, we'll be looking at how do we compute these numbers, what are the operations that we can perform on natural number, on integer, on rational number, on real number, and complex number. So till we meet again, have a nice time.